Okay, in this video, we're going to be looking at the mass number of different atoms. Okay, and just to make sure you understand, we're looking at the mass number of an atom, not the average atomic mass, just the mass number of an atom, okay, and how to find that. The mass of an atom is determined by the number of nucleons, all right? And nucleons are particles in the nucleus, okay? Which means that your mass is going to be determined by the number of protons plus neutrons, okay? Protons and neutrons are in your nucleus. Those are your nucleons. That's what makes up the mass of an atom, okay? Electrons don't count for mass. Electrons are too small for mass. Okay, so you don't consider the number of electrons when you're calculating your mass of an atom. The mass of any atom is going to be the number of protons plus the number of neutrons. That's the equation to know and memorize, all right? The other kind of big piece to know, this will be a whole number, okay? No decimals, all right? So if you're thinking about adding up the number of protons plus the number of neutrons in an atom, right? It absolutely should be a whole number. You should not have like 0.1 of a proton. What does that even mean, right? You should never have 0.4 of a neutron. That makes no sense. So, all right, so if you're looking at your periodic table, you can see that there is a atomic mass number, okay? And these are gonna have decimal points, right? 9.01, 6.94, okay? These are average atomic masses. This is not the mass of a specific atom, okay? So please make sure if you're ever asked on a quiz or a test or just to, have a basic understanding of mass number of an atom, make sure you're not just going off your periodic table and be like, the mass of this nickel is 58.69, right? You don't want a decimal. So please make sure you're just adding up number of protons plus number of neutrons. It should be a whole number. Hopefully I've beat that into you enough that you remember. Okay. All right, let's do some practice problems. Okay, the absolute easiest type of problem would be this. All right, an atom has 5 protons, 6 neutrons, calculate the mass. Okay. I would recommend for every single mass question, just write out the mass is going to equal your protons plus your neutrons. And now you just plug in. So your mass of this atom is going to be 5 protons plus 6 neutrons. Again, easiest type of question you could have, okay? So your mass is going to be 11 and your unit should be AMU, atomic mass units. This just means atomic mass units. It's just a unit that we use talking about mass of protons and neutrons. Okay, that one's easy. Another easy type of question you could be asked is you're given the mass, right? So the mass of an atom is 31 atomic mass units. The number of protons is 15. Find the number of neutrons, okay? So same thing, just set it up that the mass is equal to protons plus neutrons. And now plug in what you know. Okay, you're given the mass. So you have 31 equals 15 protons plus how many neutrons you have. Minus 15 from each side. That cancels out, and 31 minus 15 should be 16 neutrons. All right, these are easy. A medium-ish question would be something like this, okay? Bromine has a mass of 80. How many neutrons does it have, okay? In this case, I need to be able to figure out how many protons bromine has. And the way I do that is by finding bromine's atomic number, okay? If you just quick look at your periodic table, you find bromine, atomic number is 35, which means it has 35 protons. Okay, so its number of protons is 35. Okay, so now I know my protons, I know my mass. Now I need to find my neutrons. Okay, so mass is equal to protons plus neutrons, right? Everything in the nucleus. Protons plus neutrons gives me my mass. So my nucleus gives me my mass. So here we go. 80 equals 35 protons plus my number of neutrons. Minus 35. Cancel these guys out. And I should get 45 neutrons. Okay, the only extra step is that you have to make sure you remember that atomic number tells you number of protons, okay? Hopefully that makes sense for calculations. Now let's look at how you actually show the mass, okay? So there are multiple different ways to show the mass number of an atom. And one of the most common ways is something called the complete chemical symbol. Okay, the complete chemical symbol, sometimes it's called the isotope notation. We'll talk more about isotopes in just a second. But either way, okay, you will, I'm sure, come across something that looks like this. A up top, a Z down like a subscript, and then a symbol. Okay, this would be something that you'll see in your book or online or something. Okay, so A here, Z down here, and then whatever your chemical symbol is. All right, and your A, let's find a different color here. There we go. All right, your A is going to be your mass, and your Z is going to be your atomic number. Okay, if this looks terrible to you, it's because it's the generic version. I hate these, okay? But just, I want you to at least see it because it's in your book, all right? So let's look at an example because I think that makes more sense, all right? If I wanted to look at, for example, fluorine, right? Fluorine right here, okay? So the chemical symbol for fluorine is F, okay? The atomic number for fluorine is 9. And then the mass number for fluorine, we can, you know, one of the different types of isotopes of fluorine would have a mass number of 19. So this would tell me, this complete chemical symbol would tell me that this is fluorine, atomic number 9, with a mass number of 19. So this is fluorine 19. That's another way we would write this out, okay, is instead of writing the actual complete symbol for it, you'd write it out, okay, in word form, quote unquote. So you could say like this shows me fluorine 19, or you could literally write out fluorine-19, okay? This is the other way you could write it. So this tells me that I'm dealing with fluorine, okay, that this tells me what type of element I have, and then the -19 tells me, aha, this is my mass. Okay, just do like 2 other random examples here. All right, so if we had sodium or if we had gold, all right? So here we go, sodium. It's right here, atomic number 11. So 11 goes at the bottom. And then you could have sodium with a mass number of 23, okay, whatever. There's a whole bunch of different isotopes. We'll talk about isotopes in just a second, but this tells me that this specific sodium has a mass of 23, okay? And I would write it out if I wanted to like word form, this would be sodium-23, okay? You would never see something like if I look at my periodic table here, sodium has a average atomic mass of 22.99. So what I would never see is this, sodium with a 22.99, okay? This is a big no, no, no. Please don't do this, okay? I promise I will mark you off if you do this, because what you're telling me if you put your average atomic mass, you're telling me you don't understand the concept of what mass is, right? Because mass is a proton plus a neutron. So I can't have 0.99 of a proton. I can't have 0.99 of a neutron. Okay, it has to be a whole number. Good, so don't fall into that trap. Okay, so you might have gold 197, okay? Gold 197, all right, and this would show it. Oh, see, so sometimes we don't even put the atomic number at the bottom here because it's implied, right? Gold has to be atomic number 79. That's it. That's how it's defined. So you might, you know, you might have the atomic number not showing, and it might just show you that this is fluorine 19 without putting the 9, because fluorine has to have a 9 as the atomic number. Gold would have to have the 79 as the atomic number. Sodium has to have the 11. So these numbers right here are not as crucial as showing the actual mass number, okay? Ooh, hopefully that helps. There you go, mass numbers.